Hello, I'm Carol Ann Riddell, and this is Science and You. At some time in our lives, many of us will sadly have experience with dementia or Alzheimer's in our family or with a friend. But scientific research continues with breakthroughs in treating or slowing the progress of the disease. Still, too often there is the forgotten patient, the caregiver. The emotional toll can be tremendous and affect every aspect of life. Tina Beth Pina met one mother and daughter who shared their very personal story.
How's your memory been lately?
Terrible.
Oh, boy.
Short-term memory.
Yeah?
Just ask me about 50 years ago and I can tell you everything in detail.
88-year-old Gladys Krasner was diagnosed with dementia approximately 7 years ago and is fighting tooth and nail to keep her cognitive abilities under control.
I make a lot of notes to myself, and that does help. And I have post-it notes all over the place. My bathroom mirror is riddled with them, and the kitchen cabinets. But other than that, I don't really have any tricks.
There was one time where she just knew she couldn't remember something that we had been over several times. She came out of the bathroom with one post-it note on her forehead and one each on each cheek, and we were laughing about it. So she was a little bit able to laugh at herself, but you know, that's the in front of me. I think there are other times where she's trying really hard to hold it together.
As Gladys's primary caregiver, her daughter Cindy has been a crucial factor to the quality of life her mom is living and has worked hard to understand the science behind her mom's condition.
I've gone to conferences to learn as much as I can about brain imaging and brain functionality. Understanding the science behind it has helped me understand a lot more that this is not about my mom doing more and be able to do something to improve her brain. It's hard to watch your parent decline.
Dementia is called a journey of grief. So living in that arena, in that environment of not knowing what's coming around the next curve, it's very, very exhausting, emotionally, physically. I find I have to be far more concerned about my caregivers and their physical and emotional and mental health than the people that they're caring for.
According to the American Psychological Association, dementia caregivers often experience stress and high levels of strain in the caregiving role. The challenges they face are very different from those of the average caregiver. They can sometimes suffer financial hardship and often ignore their own mental and physical health.
You have to take time for yourself. You have to be kind to yourself. You have to do whatever it is that gives you joy and pleasure. I scrape far more caregivers up off bathroom floors and carry them out 911 than I ever do the people that they're caring for. Stress is a terrible thing.
Are the caregivers the invisible second patient?
Absolutely. I think they're actually more of the primary patient. The medical piece is nothing. It's all the psychosocial issues that these illnesses force families to face. Not everybody's meant to be a caregiver. The healthiest thing somebody can say to me is, I can't do this.
Coping strategies for dementia are individual, and the management of it requires a comprehensive plan that includes a partnership between doctors, healthcare workers, and families.
This illness requires a team, and that way we become the bad guys, and the caregiver can pretty much say, Mom, I'm really sorry, but this is what the doctor said we have to do, and I'm really sorry, but I have to follow the doctor's orders.
I attend a caregiver support group, which is extremely helpful to me. Other people are going through this journey, and it's sharing of feelings, frustrations, tips, advice, resources. So I would say that that's really very crucial to sustaining yourself through this journey of dealing with your feelings about what it's like to go through this.
But not all the psychological hardship thrust upon dementia caregivers is negative. There can actually be an upside.
I've learned more about who my mother is, the underlying personality, and what she's about. So that, in a way, is a wonderful thing. It's a gift. It's made the time more precious.
When she watches this, is she going to remember having done the interview, or is she going to wonder why she agreed to do the interview?
I suspect she'll wonder why she agreed to do the interview. She may remember it, she may not. My mom said that if her being interviewed could help somebody else, that's what she would like to do. But you never really totally know what memory is going to stick.
The emotional toll on caregivers cannot be underestimated. And I wanted to thank Gladys and her daughter Cindy for agreeing to bravely put a face to dementia. For Science and You, I'm Tina Beth Pena.
The weight on your heart and soul as you're a caregiver can be overwhelming. And there's a lot of statistics about spouses, caregivers, predeceasing the person with dementia or Alzheimer's because of all that stress. Having said that, though, it is also an opportunity. And I think part of our message that we're trying to get out to people is, on the one hand, taking it seriously, understanding what the consequences of the disease and the ramifications for the whole country and for the planet, but also knowing that we have found ways for people to live with this for as long as they can. And we have found ways to provide relief for caregivers and to help them see this changing person and accept them in each stage of the change, and to be able to, in some way, let go of who the person was and stay with them always as who they are.
Another area where science is making major advances, human genetics. CRISPR, a kind of genetic scissors, has been around for a long time, but researchers are using it in a new way to change the genetic code in cells to fight cancer and other diseases. Here's Donna Hanover.
CRISPR stands for Clustered Regularly Interspaced Palindromic Repeats. It's a bit of a mouthful, but the easiest way to think about CRISPR is it's a technique that we can use to change DNA, to edit DNA. That's what it is at its very, very heart. And the reason that we might be interested in editing DNA is when we find, through, say, sequencing studies, we find a mutation that we think has something to do with a disease, like autism, cancer, diabetes. What we might want to do is really test to see, does this mutation cause this disease? And so the CRISPR tool is a wonderful way for us to very efficiently inactivate genes and test, if I inactivate gene A, does it cause cancer? If I inactivate gene B, does it cause MS or Parkinson's?
Lead investigator Dr. Neville Sanjana at the New York Genome Center says it's like a scissors to cut out and change small sections of genetic code in cells in the lab. How does it work? The CRISPR system commonly used is known as Cas9. It has an enzyme that's a short piece of DNA protein and an RNA molecule.
The RNA component of the CRISPR system guides the protein component, the scissors, to a specific place in that 3 billion base pair genome and tells the protein where to make the cut.
How do researchers physically accomplish this?
It's a little bit of liquid that we deliver into the cell, and either using an electroporator like that, we can shock the cells and make little holes in them to deliver it in, or we can bind the DNA together with lipids, fats, because the cell membranes are made of fats, and so if we bind it together with some fats, that tends to be drawn into the cell. We create the CRISPR constructs here in the molecular biology wet lab, and then we go into the cell culture room and deliver these into cells. And then after a few days, to validate that the CRISPR actually worked, we take the DNA out of the cells and we visualize that DNA using something like the gel electrophoresis you're going to see. It uses charge, DNA is a charged molecule, to separate DNA by size. So what happens is that bigger molecules of DNA, longer molecules of DNA, don't run as fast through the agarose gel. But smaller pieces of DNA run much faster. And that's why you see these bands in one lane running down the gel. And the two bands reflect that the editing process has happened.
And how do researchers know what the change in a cell means?
We look at things like, how does the cell grow? Does it proliferate out of control? This is the kind of very clear phenotype that we associate with cancer, a tumor that can't stop growing.
Dr. Sanjana says a great aspect of CRISPR is its programmability, meaning researchers can change thousands of cells in different ways at the same time. Dr. Sanjana has used CRISPR to study genes that cause cancers to metastasize to other parts of the body. He also studies melanoma to find out why drugs used to treat it may work initially, and then genes cause some patients to develop resistance.
And so CRISPR has really been a breakthrough for this.
In his work on autism, Dr. Sanjana uses CRISPR on healthy cells to cut out small sections of DNA and replace them with mutations suspected of causing the disease.
Once you've made the cut, how do you put in something new?
After CRISPR makes its cut, there's a bunch of machinery in the cell that wants to repair any chromosomal break. And so if we deliver a small repair template, the cell's natural repair machinery will actually use it to insert that piece of DNA, changing the DNA from its original form to the edited version that we want to put into the cells. A lot of what we've done in the pre-CRISPR era has been just observation. We look to see when we see an organism or a human being that has a particular disease, we maybe look at their genome, we read the DNA. But what's been lacking really has been the ability to write the DNA.
What does the future hold?
Gene editing is really just 50% of the task. The other 50% is finding ways to analyze the cells we create. We need to be able to analyze these cells and say, after we create the mutation, do the cells look like the kind of cells that are involved in diabetes or cardiovascular disease or in autism or in cancer? And really the quantum leap forward with CRISPR is that it's now quite easy to make the mutations. But still that second step, seeing whether the cells actually have something that looks like the disease, that's still really quite a challenge.
Meanwhile, while genetic research has largely focused on the 2% of the human genome that codes for proteins and which is familiar to most of us, Dr. Sanjana says the part that doesn't make proteins comprises 98% of the genome, and these regions are also involved in disease. His lab is developing new CRISPR tools to explore how this part of the genome works in pursuit of more answers for medical research.
I think I'm just incredibly excited by the confluence of biology and technology in this field, which I think is a fantastic thing to have the opportunity to work on things that can affect people's lives in such a positive way.
So as genetic scientists improve and expand their use of CRISPR, hope is rising. In the fight against some of the most intractable diseases in human history, they have a tool that may finally help us win. I'm Donna Hanover for Science and You.
When we talk about the environment, it often relates to rivers, forests, even the air we breathe. But as our Ari Goldberg found out, there's plenty to learn right here on our New York City streets.
People really don't know exactly what environmental science is about. You know, it's kind of this, yeah, it's exciting. People know about climate change. They can resonate with that, but the specifics and the details, people, I think, are still catching on to that.
Chris Box is a professor of environmental science, but at Medgar Evers College, environmental studies doesn't necessarily mean a trek out to the forests.
New York City, right? It's not, it's one of the most urban environments in the world, right? But one of the great things about New York City, it has all these micro pockets of environments. So many buildings. Those are individual environments themselves that need people to assess them.
The beauty of it is it's the very communities who live here that get to be invested in the caretaking of their own environment. Box's own students.
Medgar Evers College is a predominantly black institution. You have students from all over the world that come here, primarily from the Caribbean, Africa, the Middle East, and also Eastern Europe. And we embrace the K through 12 explicitly.
And they're just wrapping up a 3-year project collecting samples from all across commercial and residential areas of the city and using some very cool tools to do it.
Overall, we collect water, air, and soil samples, and we quantify the amount after identifying the contaminants in these samples, and we compare those with standard guidelines that are issued and formulated by the World Health Organization, WHO, and then the EPA, the Environmental Protection Agency, so we can get an explicit comparison of how much we're, tolerating these toxins and if they're bad for us. So after we take the samples, we process them, we make a dilute solution that the instrument can actually readily read. Then we measure all of these vials. We had 800 samples, representative of New York City soil samples. And then we measure the potential toxins in an instrument called a gas chromatograph mass spectrometer.
Gas chromatograph mass spectrometer.
Yes.
A bit of a mouthful, But what this machine does essentially is identify contaminants in a water, soil, or air sample. The first part, the gas chromatography, separates substances and can give a strong indication as to what chemicals are present. And the second part, the mass spectrometry, identifies and quantifies those chemicals definitively. In short, it can tell you what chemicals are in a sample, and therefore what chemicals are surrounding us in our daily lives. And that can have real ramifications.
New York State has the highest incidence rate for cancer. We see it face to face. People who are living with these ailments, various forms of cancer, or adverse kind of short-term acute effects like respiratory problems, daily headaches, et cetera, et cetera. And so in a nutshell, we try to give them a map, kind of, outline. For instance, if they have a backyard, this is what your backyard is made of. If you're trying to grow something back there, you should be aware that this may have this levels of lead in it, or cadmium, or something that can be deemed potentially carcinogenic.
But what Box and his students have been able to do is while they're getting in the field training, they're simultaneously really serving the community.
We do more, actually, and more extensive work than what the government would likely do on a general sense. But when you think of soil, it's like this kind of, okay, it's there, but really, why do you need to measure it all the time, right? But you actually do, because you're breathing stuff that's coming from the soil all the time. So you have about 1,500 also, or more, community gardens throughout New York City. And a lot of them are strategically in place in areas where they don't have access to foods, right? Good or the better foods through supermarkets and so forth. And when we tested some of these residential areas, we found a lot of stuff you wouldn't want in your environment.
Let me ask you, you find these data samples and you find, there's more pollution than is allowed for the soil here. What's next? Does someone have to clean it up? What's the response?
Once you communicate with the DEP and the DEC, they have to bring someone out to remediate your soil. And they don't have to spend the money. The government actually has to aid you in bringing you that material to remediate your soil. So that's the exciting thing about it. So we're really trying to give communities a voice of what they're interacting with in their everyday lives. We work from all age groups, really all religious groups, ethnic groups. Everyone's welcome as long as you were willing to do the work.
The work they do here at Medgar Evers helps us keep an important perspective. When we think of the environment, we can't just think about the farms where we get our food or the oceans that we're swimming in. It's also about our day-to-day lives, right here, the streets we walk on in New York City. For Science and You, I'm Ari Goldberg.
And joining us now to talk a little bit more about this effort is Professor of Environmental Science, Chris Box. Thanks so much for coming in.
Hey, good morning. How you doing?
Very interesting stuff that you're working on.
Thank you.
I thought that Ari made a really good point at the end of his story about how we all sort of think about the environment as something sort of outside of our day-to-day experience, but in fact, we're all affected by it. Do you think that that surprises people?
It surprises people because, when you actually think about the environment, you have to really think critically about it. And then that requires some education, kind of from the perspective of long-term education. So usually that's the missing gap. And why
it feels sort of abstract to people.
Right, and so it feels abstract. And anecdotally, I can just say an example of that is you have environmental science. When people, for instance, go to buy their homes, they don't necessarily think what's really underneath my home and whether I should buy it. So that's a kind of another layer of thinking that people may not think about. But I'm here, my sole purpose is to educate. So I try to fill that void, connecting not just academics, students, people in my own in the CUNY system, but working with people throughout New York City from environmental-based activist groups.
Really, to the practicalities of all of this.
Right.
Yeah.
So they can see it, full-fledged. Yeah.
So this has been, if I'm right, about a 3-4 year project for you. You've been collecting samples across the city.
Yes.
I'm curious, and then you measure those samples for contaminants, is that correct?
Yes, exactly.
So I'm curious if you've found a lot of variation from one part of the city to another.
Yeah, I mean, New York City is one of the most diverse places, and it's also diverse in contaminants as well. And that's primarily from each borough. You have both commonalities, and then you also have major differences, and they're primarily sourced from humans. What's the different factories that are in, let's say, Brooklyn versus Queens, and that's really the direct source that delineates any differences. But usually you have homogeneous similarities between the boroughs because people drive throughout all the boroughs. So,
Sure.
you know,
So there are things that are the same and things that are different. But is there one area or neighborhood that you would be particularly concerned about based on what you found in your research?
Yes, I mean, primarily Brooklyn. We focused a lot on Brooklyn and also Manhattan. And that's primarily because Brooklyn, especially, a lot of people are moving towards Brooklyn because of a lot of opportunities, you know, entrepreneurship. And so we try to work with these activist groups, connect with people who are moving in to try to educate them to think really critically about the infrastructure they're moving into, not just coming here for jobs, but also kind of having a holistic picture of that.
So is it also driven by the population moving there?
Population, movement,
growing.
Yeah.
I was interested in some of the things that I read and I heard you talk about in terms of dirt, because I think as New Yorkers in this urban environment, we don't really think of ourselves as elbow deep in dirt, but in fact, it affects us.
Yeah, and that's an excellent question to think. That provokes a thought of the earth. How do you view the earth, right? And the earth is a breathing system. Just because you put cement on top of it, that doesn't mean the earth is still not breathing.
Right.
It always has gas, air moving through it, and even cement as well is not a barrier for movement of air because the earth is. Cement is made from earth and it has porous material in there, so the earth is always breathing.
So we don't think of ourselves as surrounded by soil, but
Right.
in fact, we are affected by the soil
Definitely.
that is underneath us.
Yeah, even though we're in the brick city, they say in New York City, the brick environment, especially Brooklyn, is growing and building real estate, but it's always breathing, and people are always going to be breathing air.
Yeah, absolutely.
Yeah, right.
Just a last question for you, Chris. As I listen to you, it feels to me a little bit like you're building this kind of small army of citizen scientists. What's important to you about empowering people to understand what's around them?
I think the greatest thing you can impart, and that's why I love science. That's what connected me to science. I had great mentors that took the time outside of class and said, Box, what do you really want to do with yourself?
Right.
And that's a serious question. It's not just come through an academic institution and then leave. It's really a heartfelt, important goal for me to educate and give myself selflessly for that. And when you connect with people, individuals, mass groups, and people see that your heart is genuinely in that place to help them make those connections,
Sure.
It's a win-win. And that's, I think, one of, not the only way, but it's a fundamental way for people to have self-change and have, take control of what they vision as their life, not just now, but long-term. So my heart is in science, and I'll always be there.
All right, well, we love that here at Science and You. Thank you so much for coming
appreciate
in,
it.
Professor Chris Box. We really enjoyed having you.
Thank you. Appreciate it.
If you're someone who wonders whether science can actually be fun, our next story might just convince you. We spend some time with Carmelo, the science fellow. Take a look.
And they're like, you have weird hair! But
Carmelo Piazza is serious about science. He's also serious about making kids laugh and laugh some more.
I can make any group of kids laugh, and through the laughter, I'm instilling a love of learning. It's all about making a kid feel comfortable, feel safe, and laugh. They're only 2, 3, and 4 one time, so why not make school fun?
Carmelo, known as Carmelo the Science Fellow, started as a science teacher, then opened his own center for science-based camps and programs. Next came the dream job, starting a preschool. We visited the Brooklyn Preschool of Science, the first of his 2 locations. On the syllabus that day, mealworms, including one crawling up Carmelo's shirt.
Everybody say, hello, mealworm.
Little scientists in training.
And I put on my hand and I was rolling. I used the magnifying glass.
The humble mealworm shouldn't be underestimated. To hear Carmelo tell it, this is an interdisciplinary learning opportunity.
I'm able to talk about what are the needs of living things. I'm able to add math connections by giving kids Unifix cubes and asking them to measure the length of their mealworm. We're able to take construction paper with pipe cleaners and make pipe cleaner headband antennas. Now the kids are pretending to be the bug, they're pretending to have antennas, but most importantly, they're learning about the function of their mealworm and its antennas. So just with this one mealworm, I'm able to connect the math and the art to the science.
Animals live throughout the classroom, part of Carmelo's mission to make children think and care about all creatures. It's also a way to build a comfort level with animals that can be harder to develop as an adult.
If you do not give kids an opportunity to see animals when they're younger, they wind up becoming the adults that shy away. And if you show them at the age of 2, 3, and 4, and you lay the foundation that animals are fun, they will touch, they will hold, they will feel.
Carmelo now has a book of at-home experiments parents and kids can do with simple household supplies. He is crazy for science, but believe it or not, he didn't start out that way as a child himself.
Yeah, as a kid, I absolutely did not like science because every teacher that I ever had just never did science. If you did have science, it was through reading of nonfiction textbooks.
Carmelo says it wasn't until college when he discovered the power of hands-on science learning. Now he's passionate about bringing that to even the youngest students.
If you motivate young kids in science, you're encouraging them to be critical thinkers, analytical thinkers. Most importantly, you're encouraging kids to make mistakes. Science is all about trial and error. This is the beauty of science, is like make mistakes, great. Make predictions, beautiful. Become these amazing, inquisitive type of thinkers. And this is what I'm hoping that my kids, when they leave my school, is what they take away. Everybody say, we are the scientists. We are the scientists. Everybody say, we make decisions.
And that's our show for today. Thanks so much for joining us. I'm Carol Ann Riddell. We'll see you next time on Science and You.